Hi guys, so at the end of the last tutorial we said we are going to do the baking because we were looking at the results of the live rendering of this, and right after that video I got into a lot of problems because originally I was using Redshift 2.6 and then lately I installed 3.006, which is the beta version. So it gave me a lot of headaches, and then I was trying to figure out what's not working, this and that. So I finally figured it out. I had to roll back to the stable version, and along the way I discovered a few things that we may have done better. So that's what I'm gonna go back now to show you. But before getting bored with going back, at least I would like to show you the results of where we're going. And since I do these tutorials from scratch pretty much, and I end up doing it for the second time, I sometimes end up optimizing more, just like my other tutorials. So in this case now we can I'm going to actually show you how we end up improving it, and then the result as well. So if I go to my folder, where's my folder here? This is work within projects tutorial. So I'm not getting a file tree, but that's what we're going to recreate now. However, if you go into the render folder, which you don't have now because you haven't done it yet, this is where we're going to go. We will end up creating our buildings, and then which I'm going to end up showing to you. So if I play this guy, so originally these buildings were taking around 40 seconds to render, and 40 seconds to, let's say, a minute, depends on your video card and the amount of CUDA cores you have. And we did the baking process, and now they're rendering in like 8 seconds. And I think we am pretty, because they're not 100% baked, because we do want outside sections to reflect some to respond to the shading. So if I try to give some more visibility, guys, here, so it's quite interesting. It's a bit blotchy still. We can optimize it and then push it even further, but the baking all these textures do take a little time. But since we have like 10 or 20 buildings, depends on how you end up going, it's just an overnight render to bake out all the textures. Speaking of baked out textures, this is what I can show as well. If you go back into the folder, under text, this is not the one, I need to go to the new one, textures, buildings. So we end up having 10 1K textures, but they are with many UDIMs. So that's what I can show you now. So this is how the baked textures look like, and that's 3x3, I think. How many files do we have here? 12 or 3x4. Because if we end up going into what our UVs now look like compared to what they used to look like, they're much more successful now. So that's what we're baking, and because of this baking, we are able to render more than I don't know, X amount of buildings so much faster. And that's just for the baking of the interiors. We still do leave the outside walls free from an emissive shader, so they can receive lights and reflections and etc. Okay, so let's get back to work to see what has been done. So if we dive inside the city source, let's hide everything else we don't need. So basically I discovered that our UVs were not really healthy. So I'm gonna let this cook for a second. Meanwhile, I'm going to bring in the other scene so we can see while this building is getting cooked. So we can compare the UVs. Because a lot of stuff that stays outside, we don't even need UVs if we don't want to bake them. Because those are going to be receiving light from the environment itself. We just want to bake interiors because that's the expensive part. So let this cook for a second. Okay, this might take a little while. It's still packing the UVs. I can show some of the other buildings meanwhile. There's some other buildings like this. Another building like this. So on and so forth. And this now all is done with a click of a button. We end up getting a nice turntable of each of our assets. We're just gonna wait a bit more for the cooking. It's cooking at the moment. 2 Houdinis. Okay, hurry up. Which one is gonna finish first? Okay, let me pause this while these UVs are getting baked, so we can continue. Okay, so the old one is cooked now. So if I look here, the one up. So this is apparently how the UVs were, and I am not sure how I missed that, because that's not good for baking, obviously. So that has been fixed now. We're gonna go back and fix that, and then even make it more friendly. So I'm gonna bring in this is another building, but I'm gonna show you now how the UV is looking, which is so much more cleaner. And I put some red nodes here to show what has been done, to be done properly. And if we go up here, look at the UVs, it's so much better. There's no overlapping whatsoever. All the windows, these are all the inner walls. Everything can be baked. It could be if we make the windows symmetrical, we can probably gain a lot of space, but this is literally baking every wall appropriately, and for our purposes it's fine, but I'm sure we could squeeze this into a lot bigger space. I think these are all the floors, upper floor and lower floor, but we are just going full interior, so sometimes necessary. But in our case, since we don't dive into the buildings, but the closest we see is something like this, so it's fine. So let's get back to work, and let's go up to our external wall preparation, which is here. So I did notice that these UVs were not really good. So after one second, let me hook that up properly. So we have this boolean for our columns, and then we remove what columns we don't need. Sorry, the exteriors, and then we do an extrusion, and then we remove the interiors, right? And then we were blasting certain things, and after we remove certain area versus just need the space, because we were taking some of this, splitting it, and then passing through another detailing to create some panels, which will go now, but I'm gonna need a bit more space here. So let's just clean up some space. And then first let's drop in a UV unwrap, because this part didn't have the UVs. And some of this is interior, some of this is outside, but we do need it in case we want to go fully baked, like a game engine or something. So this is okay for now, but as you can see, the spacing is too much, so I'm dropping the spacing to 0, so we get more space, more optimized space, but we want to distribute this to more UDIMs, so plug in a UV layout, and we're gonna, I think it's better if okay, so it's packing it. It's probably better if you change to manual, because the UV layout is a little slow. And then we're gonna change the pack into UDIM tiles, and then press on this plus tile grid and go 2 by 1, it's gonna spread it to 2 by 1. So if I let that cook, we're just gonna wait a second for this to be calculated, which is not that slow. Okay, so now as you can see, split into. So I'm gonna put a red on these just to make sure that I am following what I did. Maybe just a little bit up like that. And then I put a group delete because I did notice that I had some unnecessary groups, pretty much everything. So let's just remove everything because I had some, these guys were empty. I don't need them anymore. And then I'm going to create a new group called out. Oh, not you. This group is called out as a primitive, and then I'm gonna put a UV transform to move these UVs to an empty place, which is in this case 2. So I'm basically organizing all my UVs so they just go up there. And then these guys are also red because these are new nodes. Okay, I'd like this to be on the left because it comes from left. Now this part is UV, but this part is not UV'd, which is this part. And I did notice one other thing while we were rendering, when I end up coming up with the renders, which let's just load any of these, for example, so we can do a little comparison. So these, stop. I noticed that our edges were a bit too smooth on that section. So all we get was these little empty areas, even though we had more detail. So now in this version, we're just gonna give them a little bit of an extrusion, a little offset. So this way we can get a bit more depth to them. Like, because right now, so if you don't have the perfect angle, we want this to break the lighting, right? So we just want some lights going on and off. So that's what we need to do, adjust here. But first, let's go with our UVs. So again, we are gonna need some space. So let's bring this guy down. Okay, so we get some more space. Let's bring it down. Bring it down. So we want to create a UVs at a simpler model, and ideally then to create the cutting. So under this attribute angle 6, where we are bringing back the rest of the excluded section, so let's create another UV unwrap with default settings, but again it's going to give us a very sparse UV like here. So just bring that down to 0, so it's a bit closer. It's a bit on the edges, but since you're baking it, it's going to be fine. For painting, if you're painting, we probably needed some spacing. Okay, and then this guy is red. Bring a UV layout. Again, we're gonna change it to Udemy tiles, style grid 2 by 1. It's also red. Plug it in. Let it cook. Okay. So now, as we process this, things will change. So we need to update certain things. We need to follow up first if we get any output properly, if you're losing UVs or not. So okay, I think because we need to bake it from all the way to the bottom, so it will actually bake properly, because right now it's still using the I think the first part. So this divide will remove our UV, so we don't want that anymore. So we can disable it, and then I'm going to let this cook now to see what is the output of our UVs. Almost there. Okay, so our UVs are here, and these UVs are also here, which we moved up here. So now we want to move these UVs. So now we're gonna create another. Actually, you can copy this. Let's rename this to out. Actually, which we didn't, and duplicate these guys again. Let's name this one in. And now we're gonna bring in another UV transform, and then the values for this UV transform will be just 2. So if we look through now, we have UV our outer walls as well. So we did want to give them a little bit of a more volume, so we can do that here, I believe. Because we did cut everything, so everything is cut. So I think at this level, we need some more space, so we can do it, squeeze in another loop. And let's give some more space here, maybe a little bit more. So we were going through each primitive here. Was this stamp clusters integer to string? Okay, so how many is this? 29. This is 29. How many primitives this object has? 61. So we did want to probably just change this to, because we're not using it anymore, let's just delete it. Let's put another loop for each primitive that goes through here. I want to split those guys like this, and then I want to, this is staying behind, I need to bring this forward. This should be fine. Okay, so what I want now is to create a random extrusion using random this guy's iteration value, to create a random, maybe based on position multiplied by random. That would work. Or we could also just use the position of the because they're all in different places, so we don't even need this actually. So what do I have here is now just a primitive. So let's get maybe the let's create a random ID from the first position in the corner. So we can do that attribute angle. Actually, so let's drop in a poly extrude. Okay, and let's just drop one. We want this to just go outside. You can close the back as well. Well, we don't need to close the back, but which side is inside, which side is outside, I'm not entirely sure, so we're gonna maybe just close it in case our normals are not good. So basically we want to randomize this value between this thing. I'm not sure which side is in, which side is out, so we can create an extrusion, I don't know, 0 to 0.2, that's 20 centimeters, but randomly based on their position maybe. So then we can go down here and then say null in piece, and then extrude panel. If you go here, now we can write our expression here, which means that we want to create a random value. In order for the making it more clear, we can do it here and then just copy the information from there. So let's just do that, it's easier. So let's edit parameter interface, create a little float here. Let's say, just to break it down a bit, random value. So just so instead of writing one really long expression, we can just divide it in two. So here I'm gonna say get the point position, and it's gonna give me this thing then how to use it like we did before, but we want 0, which means itself, and then I want the x returns the x. So if you look at the example section, the first example, it says returns the x component of 0.3. So I want 0.1 or 0.0. I can put another 0, comma. I want the position exactly, and then it says x component. So it's x is fine. So 0. So first one is where am I coming from? Second one is which point? Third one is the attribute name. Fourth one is if it's a vector, you want the first one. So if you look at it, it's going to return a number. So this is obviously too big of a number for our extrusion. So we want to create a random value from this. So this is going to give us a random, but then sometimes maybe it could be too big or too small. We just want to fit that value, whatever value, to return something 0 to 0.3, let's say. So let's go here, then we can say fit 0 to 1, and then 0 to 0.2. No, we don't need a semicolon here. This should return us a new number, and 0.2, that was, yeah, so that's going to return a good number. We just need to make this a negative because we want to push it out. So just do that, and then this is going to give us a negative value. Copy this number now to the distance and let it cook. Okay, this didn't return, it didn't randomize it. That's weird. Is something wrong? No, and maybe I need to let it cook again. Let's let it cook. It's supposed to use the, oh, because they're all the same, so we need to maybe use height to be different, or a byproduct. Yes, because the edge, they're all at the same x position. So okay, that was not my plan. So we need to create a random value using these 3 points. Maybe that will definitely give something random. Okay, let's go back here. In that case, we're gonna get this guy here, and then put that, and then we want, this was the x component, this is the y component, and then another multiply y component. So that should give all the time finally a random number. If you look here, if you look here, yes, okay. So now we have something a lot more interesting than a flat surface. We increase the polygon count, but that's still a bit more interesting. And in case, okay, we're gonna do one more thing. In case our normals are not exactly correct, because if we're gonna change this value to fit from minus 0.2 to 0.2, so it's gonna give something like this. Okay. And then primitive sub, just to make everything, oh, this is for splitting it, so everything is here looking interesting. This, okay, and then let it cook. Now you're saying, but we extruded the mesh after the UV, after we make the UV, so they are now overlapping. Yes, they're overlapping, but I don't, because we want outside of the buildings to interact with the lighting conditions and with the reflections and with the objects passing by. If there's a light source, for them to receive the diffuse as well, rather than being baked, that's where we exclude this section from the shader, and it actually does receive the proper shading. So we don't, even though we are baking it, we're not going to use it. But if I wanted to create a completely game engine friendly UV space, we would probably get rid of these we'll definitely make sure that these normals are looking outside, and then definitely not have anything inside, and then definitely have an non-overlapping UV calculated, which means that we would generate our UVs after the end of this for each, not before. The reason we are doing it before is it's so much simpler. So it goes much faster, has a lot less faces. So otherwise it would be a lot longer to process, even though now, as you can see, this extrude panel is slowing it down tremendously. But it's gonna be definitely worth it once we render it with all these edges breaking up the silhouette. It's gonna look so much better. So we're still gonna let it cook. It's almost there, and then it's gonna definitely add a lot more complexity to our buildings. With all the UVs broken pretty much. Okay, let's go here. Let's look at our UVs again. Now, so some of these are now overlapped, but we're gonna be fine for the purpose of this tutorial. At this point, anyway, you already must have figured out how to create complex UV networks. You just repeat this step a few times, and you'll be just fine. Okay, and these normals we need to. Am I deleting the normals here? So why am I creating normals here? Because I do create them afterwards. I don't remember, so maybe let's go down here to make sure that it is good. Okay, come on. Okay. Okay. So that was one UV, and I believe fixed a few here. So with this part needed UVs, because with the glass we don't want to have UVs, and these outer walls we don't want to have UVs, just like the other walls actually. So maybe we should just optimize that accordingly, since we're not doing that. Okay, you know what? Let's do that, because we just want walls, inside walls and floors to really receive lighting conditions properly. So maybe we are doing a little overkill here. So maybe we do, but we have some inside parts as well. So some of these is inside, some of these is outside. Maybe we should keep it. It's just that it's costing us UV space, which means it's gonna slow us. It's gonna slow down our simulations. Okay, so there was another problem here that I find out that there was a problem here and then here. So now let's try to look after that. So our UVs were here. This is not baking properly. Oh, because we were removing the UVs here, which we don't want to remove. Attribute delete, vertex, accept UVs. So that's gonna come back now. Okay. So if I go down where we were collecting all our sections together, we can see what's not working here, which is that I see this section. So now let's find out where that is coming from. It's not coming from columns, it's not coming from antennas, it's not coming from floors, not anymore the panels. It's coming from the windows. So we need to find out what's wrong with our windows. Actually, we don't even need UVs for windows, unless we're gonna put some dirt textures on it. So our windows were here, which means it's inheriting some UV somewhere. I'm not sure. Do we have a UV here somewhere? No. Well, I'm going to remove these UVs because we don't need UVs for this section. And let's just select the UVs. So if I go down here again. Okay, so we have one more space here that we can probably use a bit better. And that would be our columns, I suppose. No, our walls take bigger space, so we can shift our columns one UV space right, so that's 3. And then if we go to our inner walls, which is this, we can say I want 3 by 1, which is gonna spread it one more UV space to the right. And now if we go further down to see where we're at, okay, we did make it a bit more complicated than this other guy from the other screen, as you can see, but it's roughly the same. It's just that this upper part was the outer walls. We got them more complex than what we have here. So let's now move forward to the render part. So we already fixed this part, which means that we need to render our buildings, which I'm not going to redo it now because we already have them, but I'm going to show you what to do next, which means now our buildings are ready for some shading work, so we can start maybe baking them. So let's turn on our building look dev. So we load one of the actually, you know what, just to avoid any confusion, that I am going to bake these. Okay, so let's go to task graph. Okay, which is gonna render my currently baked textures useless, but that's fine. So just make sure that you don't have any old building left from. I think sometimes if you leave, sometimes it overrides, sometimes it doesn't. So I just choose to actually remove them. And last time I believe we wrote them in GeoCity Walls, but I think City Walls Wedge version 1, yeah, we can probably call this version 1 still, so that's still valid. So I'm just going to delete this, and I'm going to save my file and rerun this, pause the video, come back once it's done. Meanwhile, this means that I believe I explained. So it means that I don't want one task to pick up more than 5 cores. In total I have 30, so I can run 6 at a time. So right click, cook selected. I'm gonna pause the video and then come back. Okay, so we finished baking our buildings now. We can quickly identify them by, you know, loading them back. And they're linked to our frame range. So if you look around, we have some more nice details. If you had a light, they'll just do some more interesting stuff. Obviously, this has an effect on the file size. So if it's an overkill, just don't do it. It may have been. Let's check some of the buildings. They're quite interesting. Quite interesting. This we could have done with the material as well, to be fair. Since these buildings don't move, but there are a lot of ways to do this. Still a lot of ways to optimize these things, like normal maps, etc. Okay, so we have our buildings. Cool. So now we need to see how they render. Right. So let's go into the shop network. I don't think we did that before yet, but so we have these materials, right? These are just materials with just random information, and there are as many as what we already made. Here, based on our material names. So we remember if you load one of the buildings that we did in the past as well, add the new ones, and then we can blast one and just keep, because if we load one of the buildings here, and we split them based on as we pack them. So ID 0, primitive 0 is the building, office lights, ads, etc. So if I blast one, unpack, I will have my primitive groups which I assign my materials to. So ID panels, I find a Redshift material called ID panels. If this was mantra, it will be the same thing. So we get a unique material for each primitive group that we originally designed. And then if I go into the office lights and unpack them, which is hard to see here, but if I get close, you'll see all those boxes that we designed. These are going to be all lights. And then what I'm doing is that I'm assembling them in with an assemble swap. So it gives me, says this object has 990 lights, and then I'm adding a point in the center, and then I'm giving them a random color, right, which we have seen here with this light randomize swap. And then it's kind of like a recap, but it's important. And then, you know, copying boxes. We don't need the UVs anymore for this one, to be honest, because they are emissive, so we're not going to randomize it away. And then they have this node called Redshift Office emission, which is here, just a noise plugged in with the color correct that goes into overall color and emission color, and the color correct version goes to diffuse color, which is output as a surface. So now, as we left it the last time, if we just activate this merge one, and then what I did next is, because this is now gonna be our Redshift proxy representation, so we can remove everything we don't need, which is light color, light intensity, and then because we are rendering from here, we need those, but not for the baking part. So let's pronull. I'm gonna say bake proxies. Okay, so now if let's call this to render. This is for look dev, this is for baking. So once we're happy, we're gonna do our look dev here. Once we're happy, we're gonna create our proxies from here. I don't need to do anything else here. So before we actually automate this, we just do a few tests. So this is our building, right? So we had this building look dev camera, and did I have any? So it changes every frame. That's fine. Let's turn this on, and let's go out to our look dev turntable. Basically, between a look dev test and a bake is just gonna be a single button, and then we just need to define how many items we want. So let's get some of these values correct. Therefore, in my test, under Redshift settings, under global illumination, I selected brute force last time and irradiance point cloud. This was, I think it was the other way around, but we're gonna double check. Irradiance point cloud was set to 32.1. I believe it was the other way around. We'll double check. I think I was testing it with the older tutorial. Okay, and then under optimization, we can probably go 224 for now. I mean, you can push it more, but we're just doing a test now, so we don't really need big numbers. 16 to 1024 is probably too high for now, so let's go 2 to 256. And right now, the let's check if the objects are correct. So we just want building look dev, and I don't want any lights, because outside I want to see what I'm going to bake pretty much right now. So then let's save before anything, so nothing breaks. Make sure that, okay, this looks good. By the way, as I was mentioning at the beginning, this is the Redshift version. This tutorial in the end will show a simple version of how to bake and assign textures in Mantra as well. So for those who are not using Mantra and have a bit more patience, can do the same thing pretty much. So look dev test. So the next thing we have to do is to just hit render and see where that takes us. Do I have any thing on and off? No. Okay. Just this part I'm not so sure, so we'll get back to that. Actually, I think it was Iridian's cache, the brute force, and Iridian's cache settings were like this. What was it? I'm gonna need to check that. Okay, let's try the same way first we started. Iridian's cloud. Let's hit random to end play, and let's try to see the result. It's gonna be like a 2-3 minutes render, I guess. Or less. Okay, let's see. Yeah, it's quite noisy, and that's because we start with brute force, and that's usually we need to go really high numbers. So I'm gonna stop this. Well, you can do your own research on this one as well. Like it's just, we just have to play with settings until we get like a cleanish enough render, and so we can just Iridian's cache. I think this needs to be quite a big number, 6 music key, and I was putting, I think, -2. Okay, let's do another render template. A lot of people use you can use the render shift zone render view as well. I just used to this, so I just use it. Okay, so the first pass is the Iridian's cache. Second one will be the brute force GI, and only then you actually start seeing the result. Okay, we're gonna wait, and then you get our result. So what we need now is probably just to crank up these numbers, do some tests until you're happy with the results. So for example, I think I'm not so happy with the amount of emission I have, but we can output this as a mask as well, to be fair, if you want to see how much light goes through, because I can see that there's some issues here and there. That's mainly because of the number of rays we're shooting, both from mostly Iridian's cache. So higher the number, sharper the image will be. But don't forget, this just we will be whizzing by these buildings. So if it's so interesting thing is that let's keep this here. I'm gonna move it on the other screen, kill the render. Now let's try to bake a texture out of this, which means I'm gonna have to put my path. For now it's gonna be manual because we want to automate this. So if I copy this, paste it, I'm pasting this from the other scene, and then I'm going to, because right now our loader is linked to the frame, so I'm just going to put a 0 here. Okay, so that's where the output will be. And how many UVs do we have? We're going to have a look. It's the same as before, so it's 3 by 4, which means we can go to our render maps, bake render map turned on, and our size is 1024 to 1024 and 4 to 3, so 4 by 3. But what I'm gonna do now for testing purposes, I'm gonna put it to 256, and I'm going to hit render to disk, and it's gonna open and play, and it will start rendering our maps. So if we open our folder, which is going to overwrite over my texture folder now, which I'm not very happy with, but that's the tutorial. So if you go to sci-fi chase, this is going under, as I said, text buildings, well, here, building project, tutorial, text, buildings. So we are overwriting this guy now. as you can see. So this is gonna take a bit longer than the beauty itself. So we're gonna pause the video and get back. Okay, so the baking process is finished. So we can have a look at the, this is for the first building. We can have a look at the textures. We obviously made them a bit small for the speed's sake, but these are all the, all 4x3 12 UDIM textures baked. Obviously, I think we can do a little comparison to see, because this was for testing. We remember we dropped the resolution to 256 by 256. Is obviously quite low res. So I think an overnight bake of 1K maps, at least 1K maps, is gonna make a big difference, because these ones are gonna look too blurry. So let's do a little test then. This was our building, and our original render was here. Still the same one, right? Yes. I'm gonna move this to the other monitor. So now what we want to do is to create a new shader version for this asset that uses these textures to render. So we'll go on our shopnet, and we're going to create a Redshift network, and let's call this baked interiors texture, or baked, better than baked, let's call it optimized textures. Optimized textures, and let's dive inside. I guess we can, at this level we will have to promote some stuff, but let's go inside first, and then we're going to create a texture sampler, RS texture sampler, and then we're going to create a material, RS material, and then we're going to connect the out color to emission color, out color and overall to emission color, and out color to surface, and we're going to expose some of these parameters so we can use the textures like file name. So let's go up one level, select our shading option, and then edit parameter interface, and then we can say from nodes we can go inside optimized, and then Redshift material. No, I think it's here, material ID. We can, in order to play with this, we can move it here, apply, and we get all the settings here. We also want to promote the file name outside, so we can play with this a bit easier, and when we're doing our tests. So edit parameter interface again, from nodes again, and then it's our optimized textures, texture sampler. So if I close all these, I think here we only need the file name, pretty much. Apply. At the bottom we're gonna have this. Probably nicer if we have that at the top, so let's rearrange it. Let's make this smaller so we can see what we're doing, and then let's move this guy all the way to the top. Apply. Okay, so we have it here. So so where was our texture? We baked it under this path, and which is coming from the Redshift roadmap. So let's copy paste this, and then it's for building 0. So let's pick it up, and then we need to replace the $F with the UDIM settings, which is called in you can find this in the within the help files as well. If you do this UDIM curly brackets, not the smaller and bigger sign, and it's gonna work just fine. So I'm going to pause the video now so I can check my settings to do a test render. Okay, and then now was a little interruption, so we can now, this one is called optimized textures. Okay, so let's play with the settings. We will be able to so based on how much contribution we want from the environment or not, we need to play with the reflection color, base. We should have the reflection, general settings, colors. Probably it's better if you just adjust it from here. It's gonna be easier because it's a bit more optimized here, to be honest. Okay, well, we have the optimized texture. We can play with more often after. So because I don't want to break my look dev geometry, I'm going to create some space here to create a renderable version that is using this shader. So let's create a geometry node, and let's I guess we can rename it building optimized. Dive inside. We're gonna object merge. We're gonna object merge to render. Guess we can, or maybe, yeah, I guess this should do. We can just bring it here. I guess to render, because we were deleting some attributes here, so I'm not sure if I want to delete them, because these attributes are required for instancing lights in Redshift in K, but we are using the texture shaders, we are using texture emission, so yes, we don't need them, so we can actually keep them deleted. That's fine, which means to render the last node is okay. So then now what I don't need, just to make sure that because this is going to be the one that we are baking, so we make sure that we don't have anything that is not needed. And there's some colors that we can use as well, but I don't need any of this pretty much. I don't need the name. I think the Redshift proxy node does that, but that I just make sure that it's I keep it clear pretty much. So then now I have the groups. And there's one group here which I don't need, so let's do a group delete. It somehow made its way, which is this guy. Okay, so I have the material, which I'm not gonna need because we need to reassign the materials basically, so we can delete the material as well. Okay, so now we have the baked material, and we have the groups as well. So let's reassign our materials. So this time we're gonna need 5 groups. First one is gonna be ID emissive, and we can select our ID emissive. We don't have it here. And then we can go to the next one, and then we want our gloss to be calculated as well. We don't want it to read anything from anywhere, so RSID gloss. Okay, so the third one is ID panels. So we want ID panels to be receiving lights as well, which is coming from outside pretty much. RSID panels. Fourth one is going to be ID frame. That's the edge of the window, so we don't want that to be calculated as well. ID frame here. We should have ID frame. And then the fifth one is everything but these guys, in case we skip something, which is gonna be optimized textures. Okay, so let's go out. So we use this one, so look dev. Let's call this optimized. Okay, this one doesn't need. For now, we'll start one by one. We don't need any lights at the moment. We don't want to bake anything, and then let's make sure that this is the only thing we're using, which is this guy. for testing purposes, actually, let's render the old one for once as well. So we want to render the look dev, which uses the shaders to render our building with GI on. So we're gonna go here, Redshift, GI as usual, not here, sorry, this one. So it's gonna be Radiance Cache, Brute Force 2, Brute Race. I guess we need like at least 2K minimum to have something less noisy. And let's hit what are our sample settings. Maybe we drop them down, they're fine. Go maybe 4 by 128. Let's do a render to and play. But remember, these are 256 kilobyte resolution pixel, 256 by 256 pixel texture, so they're gonna be quite blurry now, but because they took like, I don't know, 20 minutes to bake at most. And this one is using look dev, so let's keep this on top. Let's go object. Now we're gonna switch to building optimized, and if I didn't set everything wrong, it should render something similar, if not the same, but we don't need this time all these high settings. 2 by 32 maybe. Let's render to see what comes out. Okay, our emission settings are probably not correct because it looks like our lights are off pretty much. So let's go to our shader. And maybe dive into our overall. Maybe our emission weight is too low. Do I have the emission weight? Okay, our emission weight was close. Our emission color is coming from the shader. So let's hit the render again. Okay, right now there's a big difference because our texture maps are very small, but once we crank these values up to at least 1K and increasing the while we bake, we will have to increase the where is it, I guess the settings. We need to test these and we need to get some proper numbers, which I'm going to bake after this tutorial. But based on the previous buildings that I already did, they were giving these renders which were pretty already good, but we had these other lights that I'm going to show how as well, some environment lights, so we don't get the black areas. So let's maybe turn those on just for the sake of testing. Let's optimize, so we want our advertisements as well. We want our candidate lights, maybe external light and environment light. I think I want my environment light to be a lot less strong, even like that. And then let's do another render. Okay, so what I'm going to show next is how do we use PDG to get that automated. So once we press this button, we bake all the textures, then we bake all the buildings to make render ship proxies, which we'll do next now, And then how do we render them all and then make a contact sheet? I believe it should load. I should have them, but I don't have them at the moment. I thought I rendered it, but I guess I didn't. And then makes the using the image magic, as you might already seen on the Houdini tutorials. How do we create a contact sheet out of it? So let's get to that now. So the other thing that we want to make sure that we have the most optimized solution for this huge scene that we're going to run on our home computer is to create the render shift proxies. So basically a render shift proxy is take this state of this geometry and bake it to a render shift object that can render just as a proxy, so it never actually does any conversion during render time. In order to do that, we need to create our proxies, which is going to be under here. We can put a null object. Let's call it out mesh. Under here, we can drop in a redshift proxy output. Redshift proxy output, plug it in. And under the archive settings, it's automatically connected, but I just do it, it's a habit. So now we need to create some smart naming convention so it works with the PDG, but I'll get there now. Actually, we should probably test before we do anything. In that case, I'm gonna fetch the path from the other scene, which is here. So I'm gonna call it, I already have it, right? I wanna do the 0 first, I wanna overwrite this. So just select it and then pretty much hit render to disk. So that's gonna be output from Houdini as a redshift object, which is now done. It's the new one, okay? So now we need to set up a network to render these. So how do we render them? I'm gonna turn this off, I'm gonna turn this off. We're gonna create a new geometry node. We're gonna say building proxy, maybe building RS proxy. So there's a redshift tab here. This is like just converting this to like a packed object to do instancing almost. Right now I'm gonna do it manually. So under the proxy, enable proxy file, copy paste, and we're loading 0. So as it is, it's not gonna do anything, but what we can do now, it needs to do is that because empty, it still doesn't know that it's a proxy object. In here, we need to put a redshift proxy swap. And as soon as I do that, it fetches the address and it gets the bounding box. So then if I go out and replace the optimized with RS proxy only, now we have something a lot more optimized. And if I put render and play, it should render the same, but the loading times will drastically change once we have so many of these objects. All right, cool. Okay, let's close this object. So let's set up our PDG network. I'm gonna put this on the manual. Just wanna push these guys down a little bit. Okay, so let's create a PDG network. So let's go drop in a top network here. And then we can, I guess, pull this down a little bit. Everything is same color. Let's organize this a bit more. Okay, we can say, because this part is pretty much a live section, this is our optimization section, and these are output. We're gonna name this bake and render. Okay, so let's give this guy a different color maybe. Let's pull this down. This network can be, okay, so this part was the environment. Let's make it green. This part is the look there. Let's make it blue. This part is a bit more crucial, so we're going to pinkish. These are the buildings, so that's going to be our environment, which we are going to replace each one of these buildings that we showed before. with all our proxies with textures. Okay, so let's dive inside. On top, we're gonna drop in a wedge node. This is gonna be responsible for changing the buildings. Change building. Okay, after the change building, so we need to specify. So we have 10 buildings. We have 10 buildings, and we want to export this to the environment and create a parameter to wedge by pressing this plus button. So now what we want to change is the attribute that's going to change the building. So let's enable this target parameter, and then what we want to create this wedge parameter, which is going to be an integer, and it's going to change from 0 to 9 because we have 10 wedges. Okay, so now we need to find where we're gonna affect with this tool is actually what we're loading, which is gonna be this. So then, which means we need to change this last digit because we have 10 buildings and just 0, 1, 2, 3. So which means that this number, instead of frame dependent, now it's going to be attribute dependent. So we can do edge ID. Well, actually, I'm gonna do it like this. So if I want to override it to scrub it, it's gonna be easier. So let's just create an integer here, and let's call it wedge ID. Wedge ID. Okay, and then apply, and then type here @ wedge ID, and then I guess we can then copy paste this to here. So like this, I can just actually change it, override to see what I want to load without going to the TOPS network. So now this is linked, which means that when it needs to process, that's how it's going to process. And so the second step was for us to we need to, where is it? Out network, not TOPS. Second step is going to be baking, but I want to partition now everything by index. Partition by index. So because this is going to create an index ID, and then this is going to partition them like the first wedge, second wedge, third wedge, etc. So the second thing is, now I want to run a redshift command, a redshift node. So for example, if you go Houdini native, you don't need to do anything extra because you already have a ROP mantra. But because it's redshift, we don't have a redshift mantra here. So we need to use a fetch command called ROP fetch in order to run this command. So we're going to call this bake all textures, and in the ROP path, that's where we're going to get our out look dev optimize. So this was our bake test. So we can drop this here. Actually, I think we should give it a better name. Bake textures, and we're gonna change the frames per batch to 0. What does that do is, if I do a mouse over, it's gonna give us a little explanation. By default, when this parameter set 1, each work item is cooked as a separate job. When this parameter is set to a value greater than 1, work items is grouped into batches. I think 0 is the same thing. Not sure. I think 1 should also work. That's pretty. I mean, it's worth trying, I think. So so basically, this is gonna output files to our folder, but then we need to be careful on where we are outputting our files because we need to read them back. That means we need to now also update this output folder with our attribute that we are loading the buildings from, or the wedge ID. In that case, that would also work. So we're gonna change this to 1024 as well. I probably will do a few more tests to get the noise out, to clean it up before we actually send the whole thing to render. Let's make sure that we are using building look dev. Yes, correct. Okay, let's go back to tops. So this guy is going to bake our textures it's also going to change the folder number, folder name. So then what we want to do is to link output textures and bake our proxies. So we're going to do another ROP fetch, and let's call this bake all proxies. And now, however, in this node here, we can do a little bit, I think, optimization in terms of because it's going to use Redshift, but it's not going to use a Redshift GPU to render. So what we can do in that case is, I'm going to unlock this, because by default our local scheduler is the boss, and it lets how this network should run. Because we're going to use a GPU render, and because I have only one GPU, I'm going to set it to single. So unless otherwise specified, all of these nodes are going to run as a single task, and it's never going to run 2 jobs at a time. However, that's a waste of CPU for baking all proxies. So in that case, I can go to the scheduler and I can do an override, and I can say CPU for task 40, mass test 30. So how does that work? That for my computer, that means I have a thread per CPU. I have 32 cores. So I want to always leave 2 cores alone, so I can do my other things, maybe play games meanwhile. And then I want tops to take the rest of the cores, divide it by 4 to run as many jobs as possible that is not passing more than 4 cores. So in that case, it's going to be 30 divided by 4. So now we need to fetch our, I'm going to look it here, that we put it in here. Was it here? Yes. So this is going to run this guy, and I want all frames in. Oh, this is not the render node. This is the bake proxy. This is fine. So this can be 0 as well. It's going to be a single frame. Do that on frame 0, and that should do the trick, except now I need to deal with this part. In this case, I was using wedge ID. You see, I could do the same thing here as well. It's not, they're not really very specific rules. So because for the baking proxies and the output file name, I use wedge ID, whereas on the bake all textures output, I put the path to the loader. In this case, I can also do this. It's not going to make a difference. But there is one more thing we need to be careful now, is that which texture we are loading, because in the previous one it's going to be baked. Then we need to load them properly, which means we need to define this path to be not hard-coded as it is now. So let's find out how we can link it, because that's the one that's going to be creating this integer is going to be responsible for loading the proper texture. So we're going to change that with a wedge ID. So every time the wedges change, it's going to load the correct texture. Reflection 0. Okay, so what I want to do is, we did bake these properly, right? So I think we need to set these settings a bit more smart, and then probably add some roughness, but this is completely up to you. And this is the part basically you're going to be setting up here, while it depends on how you want your buildings to look, really. Optimize textures, but I think for the optimized textures we really don't need any diffuse. So we should probably do some tests before baking it, or to see how our shader look, because all of these baked texture settings will get baked into our proxy. So it's better you guys do your tests, and then once they're looking good, then you bake it out. Okay, so now we can just double check everything. So we're changing the buildings, the attributes is connected. we're setting the partition by index. We are baking our textures. As we bake our textures, this is going to be running. The output is connected properly, and then the shaders that will load is the textures that will be shifted, connected properly. And then if we go to our rope network, and then we just want to render these. We want to render this, and I want to render this as well for doing some kind of like a turntable. So we can create another. This is for optimized testing. I guess we can create another one called turntable. Look, the optimized baked turntable, and we want this to be, I think, 32 frames, but we don't define that from here. Tops is gonna manage that. Let's put out these as a 4 slides, external RS proxy, that's fine. And we are not baking anything. We don't need global illumination. We're gonna define the settings just a little after. Let's create another fetch network here, and let's call it render turntables, so we can investigate our buildings are healthy or not in the end. And then here, though, this is where we're gonna define how tops to render what and how many frames. So that's where we're gonna say, first let's plug in our node from the out context, bake turntable. So we want a frame range, we can break that, 0 to 35, and we're gonna give a 10 degree every frame. But because I have one GPU and we don't want tops to take over to start rendering things separately, I will force it to go all frames in one batch. So it's gonna do frame by frame instead of trying to do many frames at a time. The rest should be okay. So this is gonna bake all textures. So this is a render job. This is a render. This is a proxy job. This is a render job. Okay. Obviously, we can link that tops another wedge on top to shift our buildings as well if you wanted, but we're kind of like making it a bit more granular like this. So if something breaks, we can make it look a bit easier to manage. Like we could make that a prerequisite for this to run. We could probably do a top fetch and bring it in here pretty much, but we don't need it at the moment. Okay, so I want this data to be the output at the moment. Now I just want to make sure that I have good settings for rendering. So what I want to do is, because this is where we're gonna bake our objects as proxies, so I want to make sure that this looks as good as possible before I bake it. And then I want to make sure that the textures are high quality by changing the settings in the previous render node. So if I now go to my with dev optimized, so now I think I can play with my progressive render view. So I'm gonna save and open render view. This is the redshift render view. From here I can select the rope, which is look dev optimized, and I'm gonna go bucket, so it's gonna avoid progressive rendering. And let's select the camera. Let's say render again. Oh, this is gonna render the proxy. We don't want to render the proxy. We want to render the optimized. Look, they're optimized. This happens sometimes, get stuck. That's fine, it's still the same. Look, they're optimized, so that's gonna render our optimized version. But our turntable will be rendered by proxy. Okay. And I guess we can do the same here. Okay, let's do it again. Open the redshift renderer. I think we need to do it again. clicking on it a bit stronger. Okay, render. So this should render the optimized version. It means that we should be able to play with the shader live like a progressive render. Do we need to, this is the part is it loading? I don't think it's loading the shader because we linked our shader now. We linked our texture. So let's set it to 0 for now. And let's not forget to put it back. Okay, so it's loading proper textures now. Does putting reflections make a difference? That's what I want to see. It does. And I want to give a roughness of 0.35. Actually, I want to make this as fast as possible, so I'm gonna kill the reflection because we just want reflection on the mirrors, and whatever reflection there was should have been baked into the walls when we use the high-res version. So make sure that the more we can shave, the better. So that's the reflection. We have, if we go emission 2, I think we're gonna get just something brighter, but I think we can override this in the RS. We can override some of these in the render shift proxy material settings as we and then there are some optimizations we can do. So we can say that, hey, don't do more than 3 or 5 refraction during this object, etc. So I know that this doesn't have to reflect a lot at all because it's baked. There's no refraction on this object. You can just refract once, and then we can probably put this down to 3 just to make sure that it's not making any difference. Now let's go into, I don't see the diffuse settings here. This is coating, this is overall, advanced, diffuse scale. Okay, I'm gonna dive in. Probably just break these settings and then go 0. Everything's connected to emission, so everything should be just coming out of the box as it is, straight from the texture. Okay, I think we can leave it as it is. Let's go out. I think I want to QC if the reflections are working, so I'm going to turn on in this render. Maybe just put a giant big light on the side to make sure that it's working, but we can also turn on the ads. Let's do another render. I just want to make sure that the advertisements are reflecting off the glass shader, but I believe they do. If we go before and after, maybe if we find a proper angle. Let's turn on the ads so we see them. I guess an angle like this should help. Okay, out, render. It's hard to tell from here, but now if you render it with and without, I think it's going to let us know. I don't think the glass is working. Let's go in here. Are we removing any glass? No, we're not. We're cleaning up. We have some glass. Glass shader is working, I suppose. We can check it here. ID panels, ID metal, ID glass. So what if we put a blast here to make sure that it is working? ID glass, delete, unselected. Yeah, there are glasses working. Is it? Yes, our glass is in the correct place. Okay, let's now double check again, maybe without the ads, as I said. Maybe our glass is not reflective enough, which we can play with. No, it's actually working. We can see the difference here. We are actually reflecting, fine. Okay, so that's working, that's good. We can keep, but we don't want to bake that in case we want to move the advertisements around. And I think we don't want to bake, but this is for our turntable, this is for our look dev. Okay, let's go back to the textures to plug in our bake all textures. Go here, sorry, not here, to our shader to put our the wedge. Backtick, wedge ID, backtick. Okay, so to change the shaders, that's correct. Reflection, this is the reflection of roughness is one, maybe, I don't know, I don't want to bake anything wrong. Just keep playing with these settings and then until you're satisfied pretty much. We can probably add a little roughness. It's gonna diffuse the render a bit, the indirect light a bit more. I guess that's gonna help with the shading, so there's less link to reflection, there's less noise. Okay, increase the samples as well. And this should do the fine. We don't want any gloss color. Okay. Let's put our camera somewhere like this, maybe like this. We don't need this guy. We want to animate so they can do the turntable, so we're gonna put a null. We're gonna animate this now. Let's call this rotate, and let's connect to building ads and building optimize, sorry, not optimize, proxy, so they can rotate. Let's give it, since we set 35, we need to give 350 degrees and then plus the first frame, so we can set this to 35. Okay, I'll change the frame range to 35. In the building ads, we want to visualize our out display. We want to render our out instances, which are our advertisements, and then the proxy is as it is. So if we press play, it should, no, nothing is turning. Is it because, oops, sorry, that value should be changing, our buildings should be rotating, but they're not because I'm not visualizing this, I'm visualizing this. This should be turning, advertisement will be turning now as soon as I change this to none as well, not from here but here. When I'm outside, let's go outside network, and okay, everything is turning, cool. Before pressing render, I think that's also, I'm just going to recap again. It's going to load 10 separate buildings, wedge count 10, start to end 9, which is changing an attribute of a loader. This is going to partition all my streams by index. We're going to bake all the textures, which we're going to put it back to 1K, 4x3 dims. Ideally quite high settings, so we have less noise. So I suggest just rendering this with this off, just to see what it comes out, which we're gonna do now before we hit render. We are making sure that whatever variable is connected to wedge, is hooked up in every file file outputs, so we don't overwrite any textures or objects we're gonna write out, which is also including loading the textures to render, which is here, optimize textures. The wedge ID is connected again, so make sure, so the tops will make sure that it's loading the correctly baked texture. So now Last thing, again, like I said, we're gonna do is we're gonna do a little test here to make sure that our settings are nice. So let's go one. It's gonna load a different building. Oh, this is overwritten by our top, so we can change that. That's easy. So we can wedge ID override. I don't remember how to override target parameter capture. Should be outputting it here. Oh, because we can, yeah, we can do that from here. So I need to bring that guy in here. Not that, the attribute itself. Drag and drop. If I say capture, you can't capture one. If I say it's not updating it, I want it to update. There was a way to overwrite the value backwards from here, but I guess we can do it manually for now. This is the attribute, so if I go, I guess just to make sure it's loading the correct stuff. Okay, so that's another building. Maybe let's say this is our angle. Let's do a little render now to make sure that we have enough quality to bake, which means I'm going to disable bake render map, and I'm going to open the render view. Let's save first. Open render view. There's a little setting that came with the latest oh, because I'm back in an older version, so it's not here anymore. Okay, that's fine. Okay, so let's this is the camera, but I want to render my bake textures for testing. Hit play, render, so it's gonna render, so we can play with our settings. Always on top. Always on top. So we can see it. Okay, let it render. Oh, I didn't press play. Okay, it's going to be doing, I think it's doing the irradiance cache first. Okay, I'm gonna pause this video now. Once I have the good settings, we're gonna together kick off the whole baking process. Okay, so the frames came out. I think we probably don't want them to be so dark. I think that's because I don't have any other light. Let's put the environment light and the external, not the external. Yeah, we can bake the external light as well. Let's just see how it's gonna look. It took 1 minute 56 seconds to render. Okay, so I did go through some settings, and it seems like although a little bit maybe higher quality, this value seems to be in the ballpark. Let's kill the render. That's also depend on your GPU. I have a 2080, so 8K brute force gyrates. This can be less. I think this 6 bounces overkill. Let's keep it 2 for the sake of rendering. Reflection and refraction combined, that's probably okay. If it's in the ballpark. I guess we can go less samples for min, and then max probably 512. Okay, so I think now we are ready to go. So this was our baked textures. Just before anything, let's just turn this on. Let's double check our output paths are correct, and we're gonna bake these out. So let's go out, context. What I'm going to do is I'm going to give this a separate name, so I don't overwrite. This will be backup. And then in the RS proxy is fine. We were writing in the geo, so I want to delete these. Actually, yeah, that's fine. And then textures, buildings, I want to rename this as well. So backup. And then I am ready to bake my textures. So you're gonna right click and cook the selected node, and it's gonna launch a bunch of jobs which we can monitor from here, but these will take a while. I mean, it wouldn't be, it could be probably safe to go some really low settings for the baking and rendering, and to do it at least once to make sure that it is working. It should work. I believe everything is hooked properly, but for the sake of testing, probably you can just go and like really make the texture small again, just so you do the first run instead of like 10 hours. Maybe it will complete it in 1 hour just for the testing. It's probably not a bad idea, but I'm gonna launch this now. I'm gonna save it and then launch it. Okay, see you in the next video. Before finishing, it's probably worth showing this as well. So we can just, if you want to remove everything that you did that doesn't work, you can right click anywhere and say dirty selected. You can do this, or you can say dirty selected node result from disk, so it's going to remove. So then if you want to QC if these steps are going to work, what you can do is to select each and then go cook selected, and then it's going to say, oh, okay, I already found the building, so I don't have to do anything because they're already on disk. So if you want to see how the next step works, you can select each one, and it's gonna give you this one is connected to this building, etc. So now we can select the bake texture. So what I want to do is actually, I do want to do a single test. I want to go change build. Oh, this is we skipped this. I just caught it. We did not. Did we remove the settings from here? I remember this was set already. So let's just make sure that it's correct. Target parameter was the building loading, and the attribute name we managed was wedge ID, which we said we're gonna do this from 0 to 9. So how many wedge counts? So 10. So 0 to 9. But I do wanna test one now. So I'm gonna change the wedge count to 0, and then I'm gonna go wedge count to 1, and then start end to 0, because I do want to test this. If I go right click, cook selected, it should just give me 1, which means it should bake 1, output 1, and render 1. So I'd like to try that, and then for that to work, I'm going to go and change my settings again to maybe this time 512, because I do want to see if the one step will go forward before firing and forgetting it for the whole night. So let's save, let's right click on the last node, cook selected node, and if it errors here, it's gonna error here, it's gonna error here, so we can investigate if there's any issue with our setup, which we did connect this. So ideally, if I click on this, it should go. Oh, it doesn't. So building look dev, load buildings, load building, it's error. Building look dev, load buildings. Oh, this is something we forgot as well, so maybe we should remove that also. Okay, so did error, we don't know why. Let's go and let's check why it errored. It could be the same reason. It's giving us a segmentation fault. And they start for 1 frame. It shouldn't give us a segmentation fault. Why is it giving us a segmentation fault? Let's dirty it again. Let's try again. Is it correct attribute? Oh, it's called wedge ID, so that's wrong, obviously. So let's make sure that that's correct. Okay, which means this needs to go like this needs to go like this, which probably broke our tops again. So let's kill it all. Dirty. Select dirty all. Actually, I think there's a note here. Dirty all. Okay. So now I'd like to investigate if this is gonna break itself if I launch it straight from the textures node, which is this one. So I'm gonna save it again. This is supposed to be outputting to 0. This was load. It's called the wedge ID. That's not correct. Maybe that's why it's failing. Maybe we should make sure that we are copying proper paths, because I did connect it from the other scene and then I didn't write it properly. So what about our shader? Our shader was using the wedge ID, which is fine. Okay, let's try again before saying that doesn't work. Probably connected wrong nodes. Otherwise we'll close the DD, maybe reopen it. Sometimes actually when you fail rendering or hit escape so many times, it doesn't flash the GPU memory. It might end up causing such errors. One way to check this in Linux at this is to still erroring, which is causing the rest of it to error. Let's check again. Segmentation for wedge parameter building look, the load buildings wedge ID not found. Okay, that's quite straight. So let's find what is it not finding. It says the wedge ID is not found. It says it can, oh, that's because of this building look dev, because we broke the link. That's why sometimes it's very important just to make sure that you got the right thing, or even actually that's probably a safer way to go. Object building look dev, load buildings, wedge ID. That's now probably it's better. Let's save again. Let's dirty it all. Okay, hopefully it's gonna work now. As I was saying, the one way on Windows you have a the GPU, the programs that shows how busy your GPU is. On Linux we have something similar as well. It should be somewhere here already for me. GPU stat, that should return me the status of my GPU. There's a lot of tools. So basically if it goes up to 100% doesn't error, as I was gonna say, it should work, but it still didn't. Let's investigate further. Okay, so it did find it now, but it still caused a fatal error, and we need to understand why. It doesn't make much sense to me, so I'm just gonna try closing and opening Houdini. Actually, I'm gonna try. Yes, I'm going to try closing and opening Houdini. We saved this as 02 buildings part 3. So let's close it and open it. Empty the trash can. Let's launch Houdini again. I'm typing on the other screen, so that's why you don't see it. Okay. Let's try to run it locally to see if it's gonna output to our folder, which is here, sci-fi chase, text, not this one, sorry, this one, text, buildings. So it tries to load and then it fails, so something broke there. You can keep this on as well. Let's see if running it straight from the Redshift will fail, which shouldn't, because there is not much of a difference. We're just going to make sure that everything is set correctly, I suppose. Or maybe it's supposed to be framed for batch 1. or all frames in one batch. Okay, let's try again. So this is where it's failing. The other thing that I think, make sure that maybe default headlight creation is off in case you don't have any lights, but I have. But if you don't, in your future settings, it's going to create a headlight and then your bakes will look wrong. But that should be it, really. Let's try to render to disk. Okay, I'm gonna come back once this is over to see if it's errors or not. And finally, this has been giving me a lot of segmentation faults, and I wasn't sure what was going on. I think it was sometime Redshift related. It is not in the tutorial, also in the documentation. Also, I've been going through the documentation, but it looks like, at least on my machine, for some reason, when I set GI to irradiance cache, then the brute force, I get a segmentation fault immediately. So I changed it to brute force, to irradiance point cloud instead, or you can just go like brute force to brute force, just to make sure that your textures are noise free. And meanwhile, what I also did is that since we were not using the outside section, since we do want let's go to perspective view. Since we do want only interior floors, let's say, can I select this guy? Yeah. Through this window, we want everything to be baked. All the rooms, basically. It's very hard to see from here. All the rooms and all the walls we want to be baked. What I did is that I did exclude this outside part, and I did disable the extrusion that we did, so which you can go back. It was because it was adding another 50 gig, like it was almost making the file size more than double. So I think if we need to, we should probably first distribute our buildings with these most optimized versions, and then I think if we need a higher res version, then we should probably make a separate one. So on the paneling level, I disabled UV layouts, and then on the out panel, that this is the part where we put the out panels UV settings, I disabled that as well. And then here the extrusion part, I just brought back a divide, remove shared edges to do a cleanup, and then just copying the it's on manual but doesn't show, just copying back the UVs onto the for each, which you can find all the latest file structure here, the edits here in this file. So then in the end, because our paneling was going on this upper section, so now instead of baking 4x3, we can just bake 4x2 textures, which means that on our render tiling, we need to go 4x2. And finally, with fingers crossed, I will die here, and then I'm gonna say save. We're just gonna try only one now wedge, again as I said it, so which means this should now work. Let's cook it and wait a bit so to see if it returns what we need, and if it does, we're good. Okay, waiting. GPU is running. GPUs keep running. Okay, so far it's not erroring, so I'm gonna believe that it's working. Let's go into Odin projects, sci-fi chase, texture, and now it's baking Hopefully this will go through. All right, I guess this is gonna take another 10-15 minutes to do the rest. So I'm gonna let it run, and then in the next video we'll have a look at the result. I'm gonna run these overnight for all of the buildings as well to bake out our instances. And now finally we are going to start rendering the city with all the bake textures. And then I guess we can put some architectural lighting, some city lighting, and then some volume to give it a bit more depth before we move forward to start building our traffic system. And so finally we can animate our ships to chase each other and do their FX thing. Alright, thank you for watching.